Alright, so let's do the helper video number 12. So today I want to actually talk about how to find the electron densities. So let's just say that I have s orbital right here. Let me just get that. S orbital, right? S orbital is just a sphere. So this is just like a one color, also the one phase. So either everything is positive. Oops. Everything is positive like this all over the place. Or everything is negative. Alright, so let's just say that I have these two atoms. So that one right there represents the one hydrogen atom, and then that one right there represents another hydrogen atom, right? And then I'm gonna make these things approach each other, making these guys close together. So let's see if I can do this. So if I make these things approach each other, then sometimes that minus and positive is going to cancel. So around here, you can see that positive and negative cancel, and this positive and negative cancel, and that positive negative cancel, right? So there is a region that there is no positive sign or negative sign here. So if I were to actually draw a circle like this, or maybe that's a slightly bigger circle, right? And within this circle, you don't find any positive sign or negative sign, right? So inside of that, I have 0 positive sign or the 0 negative sign. So I have 0 positive or the 0 negative. So it's basically 0 square. I'm going to square this, and then I get 0 here. That's the electron density here. Let's just try to find out the electron density from other place. So let's just try to find the electron density somewhere around here. No, that just make it slightly smaller. So inside of this red circle, I have one positive sign, right? So 1 square, positive 1 square is gonna be positive 1. That's pretty much the electron density around that spot. So basically, all of these guys, somewhere around here, you have a positive 1, that some sort of a density is on this side, right? And then all of these guys, it's a minus 1 squared. That's also equal to 1, right? So both sides, I have a good electron densities, which is 1. But in the middle, there is no electron densities. Alright, then let's do another combinations. This case, I'm gonna do the positive and positive. So you have the oneness orbital with the positive. Okay, and then the other one, another hydrogen atom, is this time around another positive sign here. So this is a positive and a positive phase on both hydrogen atom. And then I'm gonna make these guys approach together. Then what's happening here? So somewhere in the middle, I have two positive signs, right? So this one become 2 plus. Let's use that one. 2 plus. And same goes with that one too, right? And that one too. These guys become two plus and 2 plus and 2 plus, right? So let's try to find the electron density around this spot right here. Then that position in between the hydrogen atom and the hydrogen atom, right? Somewhere around here, I have somewhere around here I have 2 plus square, so which is gonna be 4, right? And same story for that one and that one, right? So electron density in between the atoms, I have 4. That's quite lots of electron densities. Now let's go back to the outside. We're talking about somewhere around here. Outside I have only 1 squared, which is equal to 1. So basically what we have is that I have high electron densities, which is 4, and then low electron density around here. And these are actually called constructive interference, because positive and positive makes the high electron densities in between those atoms. Alright, let's do the next problem. Alright, then I have p orbital. So let's just say that, what's a good one? P orbital. Actually, I should probably use this one with blue and red. That's maybe a px, and then pz may look like this. PZ, and then PY is the one that's coming out of this paper. And going into the paper, right? So that one right there is a right here. Then I'm gonna copy these things, and then actually it's okay, good. Copy this and copy that and bring it somewhere around here. Can I rotate? Nope, I can't. Alright, so I have to write out the whole thing. What actually? Group. Alright, so this is another stuff right here. Then you can actually make a bonding orbital like this, right? Just like the positive and positive, let being positive for this particular case, you can see that when I actually try to overlap these guys, the overlapped region is going to have a high electron density, right? The goal of the chemical bond is to actually place the high electron densities in between atoms, right? So that's what's happening here. Now that's good for the two molecule with the two atoms, but when you actually have maybe like two object or the three object, for example, like the BH, let me just try to get this BH3. If you recall BH3, the Lewis dot structures, and then go through the Vespa model, you get the trigonal planar, and then you should get 120 degrees in between these atoms, right? But there is a problem here, because p orbital are 90 degrees to each other, right? All of these guys, for example, like that angle is a 90 degrees, right? And then that angle is also 90 degrees, right? So how can you actually make 120 degrees? You can't possibly do that with the p use of p orbital. So does the d orbital. If you take a look at the d orbital pictures, then you will realize that you cannot make 120 degrees. So how are they actually making this 120 degrees in this BH3 atoms? That's something that we're going to have to deal with in the next quiz. So I think this is probably good enough for you to actually complete the quiz number 12. So just try to stop this.